My guest today is Qiusheng Wu. He's an associate professor in geography and sustainability at the University of Tennessee, but also a very active open source software contributor, having developed projects like geemap, segment-geospatial, or leafmap, projects centered around making geospatial computing simpler. Not only that, Qiusheng shares his work and how to use it on his popular YouTube channel. This conversation is a deep dive into Qiusheng's story, from a farm in rural China to where he is now, contributing to open source and lowering the barrier to entry. This episode is sponsored by OpenCage. If you're building any application or tool that uses location data, at some point you'll probably need to convert place names or addresses into coordinates, or coordinates back into place names. And this is where OpenCage comes in. They offer a worldwide, affordable, forward and reverse geocoding service that's easy to use. OpenCage builds on top of open data sources, which grants much more lenient licensing terms than alternatives like Google, allowing you to store the data as you want and even keep it after you stop being a customer. You can also display it on any map, all at a more affordable price. OpenCage handles all the complexity of dealing with the messiness of the real world and provides a simple-to-use API that allows you to focus on your use case. They have a generous free trial that you can use to get started with no credit card required, and they offer a clear upfront pricing with a cancel at any time, no questions asked policy. To learn more, head over to opencagedata.com. I'll have a link in the show notes. As a side note, OpenCage is also responsible for hosting the geemap events as well as the geemap podcast, for which I'll also have links in the show notes. Thank you to OpenCage for once again being a sponsor and for their continuous support of the podcast. Qiusheng, I'm very excited to have this conversation together, that we're taking some time. I don't know if you know, I like starting these conversations the same way every single time. I like asking people how they would describe themselves. How would you describe yourself?
I think I would describe myself as an open source geospatial developer and educator. So my full-time job is right now I'm an associate professor in the Department of Geography and Sustainability at the University of Tennessee, Knoxville. So my day job is doing research and teaching at the university. And most of the courses I teach focusing on GIS, software development, and database. Most of the technical courses. But in my free time, at night or my weekend, whatever, when I have free time, I love developing open source software and also contributing to the open source community. And I've developed a bunch of open source packages and data catalog for geospatial. And also, I love creating tutorials, showing other people how to do stuff with a couple lines of code, or usually no coding, and makes it easy for anyone around the globe that they can use some cool stuff, cloud computing for free, without having to have a fancy computer. So that's kind of the things that I enjoy doing. So I think, it would be like educator is describing what I do daytime at the university, and then software developer or contributor during my free time.
Is there some overlap between like the work that you do as a professor and then like all the open source and education? I was actually quite curious about that.
Yeah, so certainly there's overlap. So for example, all of the things I do in the open source, nobody is paying me to do open source. But I can also, like, for those things, you have some impact. You're getting some recognition, some award, or people using your software. You can also claim for example, in our contribution to the university mission, or even in our annual report, right? I can say, okay, my package is being used by blah, 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 by Google, by Microsoft, by AWS, right? So that means you have an impact. So it's kind of there's no clear cut that this is personal, this is work, but usually it's kind of mix of two. But if you're doing like consulting work outside the university, then you need to basically disclose to the university. So you're not supposed to use university resources for your personal gain. But I mean, in terms of teaching and research, these things are kind of sometimes, it's kind of mix of both.
So let me ask, this is a very, it's a question I probably already know the answer, but I want to ask it nonetheless. Like you said, you're not paid to do some of the open source work. So why do that on, on the weekends and on the evenings?
Yes, I think this kind of back to I've been doing like open source for a couple of years now, so kind of inspired by some of the GS people in the community. So when I was doing my PhD research, it was focused on delineating surface depressions to figure out where are the waters are, where are depressions on the landscape. So at the time, I mean, you can use ArcGIS. There are some tools you can feel the depression, you can get those size or also the shape, but there are no more to it. So you can also delineate the hierarchy, because you can think about like there's a big depression inside, there might be a smaller one, because I was interested in wetlands. But if you find the water, most likely you want to find some wetlands because it needs the water. So at the time, I used the white box. It's called white box GAT. So that one was developed by Dr. John Lindsay at the University of Guelph. It's called white box GAT. But later on, he like revamped it and then created white box tools. And now he has a company and then OpenCore and also like pay version. So basically, I benefit a lot from his research, and it was open source. Like his almost over 400 plus tools available for anyone, and just command line program, and then you can download it, you can install it, and you can also look at the source code. So I was amazed, like, wow, this is great work, and I benefit a lot. And I was trying like, okay, can I contribute to this? So I just started using that, I think in 2014, 2015, when I was finishing up my PhD. So at the time, it was, for example, a command line program. And I see it kind of like, oh, yeah, maybe I can make it easier. I know a little bit Python. And I was also trying to teach my students, for example, how to use Python. So I kind of, okay, maybe I can make it easier and then integrate with Python. So it makes it easy for people to integrate this into their Python workflow. And I was also using R. So I kind of also built the R like package for it. And then later on, like Jupyter. So kind of this kind of a starting point. It was inspired by Dr. John Lindsay. And then after I have done that, it looks like, oh, people are using that. Cool. Like it has more impact than like writing research articles, because those are usually very narrow area that not many people use. So I always love, like, if I spend some time, I want people to use it. So, and then the rest, I mean, in 2017, 2018, the Google Search Engine comes out. I was learning that, it was not perfect. And then I developed geemap. And then later on, leafmap, segment-geospatial, something like that. Yeah. So I always love, like, if I spend some time, I want people to use it. I also try to make it easy for people to use. And with just a browser, right? So lower the barrier and then anyone can use, because I came from kind of a background that's poor education background. They don't really have access to technology. So a lot of people around the globe, like, they don't have a fancy computer. They might have internet. So can they also do something? Can you show them how to do that? If I can do that, they can do it, right? So I'm also trying to reproduce, makes it easier for people to utilize. So that's kind of the things that always in my mind is, there are a lot of cool stuff out there, but not many people know how to use it. And even though those big techs, they can develop all those cool stuff, but still the barrier is pretty high. So can we do a little better, like introduce it to the general geospatial community, that people without really like programming skills, they can still use your stuff? That's kind of a long answer, but that's like a way I come from. Yeah.
We're having a long conversation. This is the whole goal of this. But I can really relate to a lot of that, especially this idea of like lowering the barrier to entry. I think a lot of geospatial is a little bit daunting. If you download one satellite image, for example, and you realize it's like 4 gigabytes. That's going to make it really complicated if you want to do multiple of these. Like all of a sudden you need 200 gigabytes of storage. Are you familiar with Kaggle, the online like machine learning competition?
Competition.
I started a lot of like learning Python on Kaggle because they had hosted notebooks with GPUs. So you could, with whatever laptop you had, you could just run on their thing there. And I felt like there was something kind of magical with everybody being able to contribute no matter, like, you didn't have to have the latest NVIDIA GPU or anything to get started.
Yeah, definitely cool. Like, yeah, I use some of those, but not a whole lot. But it's certainly they have a lot of examples and different like solutions people can learn and they can pull. But most of my stuff nowadays is basically on GitHub and also Google Colabs that allows you to install packages quickly, and then also you can allow people to contribute. I think Kaggle is more like a resource that a lot of like centralized location that people can search and find a solution, but it's not something you can build on top of. It's like if you're developing open source packages, you might want to have something that people want to contribute, and usually GitHub would be a better like solution. Yeah.
I want to dive into, like, one of the things I was curious about is to learn a little bit more about your story. You mentioned you came from a poorer background, and we started talking the other day. And so could you walk me through how you got to where you are today and into GIS and geography and computer science and all of that?
Yeah, let's make a long story. So I grew up in a small town in southern China, in Guangdong province. It's close to Hong Kong and Fujian, Taiwan. So it's close to the South China Sea. And it's a very rural area. We didn't have, so when I was growing up, at the beginning, we didn't have electricity. And then I think after 5 or 6 years old, then we started having electricity. But we didn't, even nowadays, we didn't have internet. We didn't have Wi-Fi. Or like you see here, it's very common. So if I go back home, like to visit my family, I'll be off the grid. There'll be no internet. And I didn't learn how to use computer until I was admitted to the university. I think it was in 2003. So I didn't learn computer. At the time was like just textbook. And then, so for us to get into university in China, we need to take the so-called college entrance exam. It's a very different system than the one here in the US or in the Europeans, because everyone takes the same entrance exam, and you only have one chance. If you fail, you fail. You cannot get into university. And also, you need to basically decide your major before you get into university. Unlike the US, you get admitted and then you can decide your majors later. In China, at the time, it was different. So you need to decide your major. You also need to gamble to guess like what score you're going to get, because like top university, like higher score, like second tier and also the third tier. So if you think that you're going to get to the top university, but when you perform really bad, then there's no chance, because you basically you have three choices: your top choice, your second choice, and your third choice. So if your score is not good enough to get into the top choice, your favorite one, if you go to the second one, then you will have penalty. So for example, you're getting 700 points. If you're the second choice, the university, you will deduct, for example, 50 points. And then you might not even be able to get into. So kind of like tricky if you if you did not perform well that you are supposed to do. And also for your major. And for university, when you apply, there's a checkbox whether you want to be allowed to be assigned to a certain major. So you can get, for example, the same university, different major. For example, my parents wanted me to study, go to medical school. And my score is not high enough to get into medical school of the Sun Yat-sen University, the top university in southern China. But my score was high enough to basically pass the bar of getting admitted into university. And because when I check the box that you can either choose to study at this university, but you are being assigned a major that you don't pick. Otherwise, if you don't check that box, you are out. You cannot get into that university. So I checked that box and I was assigned. So I never signed up for doing GIS in 2003. So I select medical school or whatever. My parents wanted me to become a doctor because they know a doctor going to make money and save people. And it's a way expected profession, like a profession in China. So my score was not high enough. but I was able to get into university, and then he was assigned to do GS. And at the time, it was just got started. Nobody know like what exactly is GS. Even my high school teacher, they have no idea. They saw I just going to do like mining, find out where are the gold mines are, like those are the GS. So it's kind of by accident. So I go into GS by accident because in my high school, I also studied chemistry, some physics, and something like relevant. I probably picked like atmospheric science, but for some reason, I was assigned to do GS. And then I think in the first 2 years, we're kind of studying all the basic geography, all the mathematics, and some of the common courses needed for the major. And at the time, like I think 2004, 2005, then Google Earth released. Probably 2005, right? When I was a sophomore at the university. And I was amazed by like the satellite and all the stuff. And then later on, learn all the Esri ArcGIS software, starting from ArcView 3 point something, and then ArcGIS like 8.0, 9 point, like all the way. So I used it for a long time, like almost 10 years. And so I went into college, finished my master degree and bachelor degree. And then I was admitted into the graduate school, also at the same university, in the same school. I studied for 1 year and a half. And my PhD advisor, at the time he was at Texas A&M University. He went back to China for a conference. And so I met him, and then we talked, and then he needed a research assistant. And I would like, yeah, I'm interested. So the funny story was my ex-girlfriend. He came to the US first. He was like 1 year ahead of me. So he came to the US, and he wanted me to also come to the US. And I've never imagined they would come to the US. Usually it would be just graduate, find a job in China, and then make some money, and then close to my family. But so I finished all the exam, and then passed, and then got the admission to Texas A&M. Everything was settled. But before I came to the US, I think 2 weeks before my flight, my ex-girlfriend broke up with me. So I was like, should I come or should I just like just quit? Eventually, I came, and then went to Texas A&M with my PhD advisor. At that time, was my master thesis advisor. And only after 1 semester, then he moved to University of Cincinnati. And then I followed him to University of Cincinnati. So I finished my 2 years master and also 4 years PhD with him. And then graduated in 2015. Yeah, that's kind of a long story that is by accident. I'm not supposed to study GS, but I accidentally studied GS. I was not supposed to come to the US by accident because my ex-girlfriend, so I came to the US. And after that, I worked at the university and then start teaching GS, and then getting into open source geospatial. And then the last couple of years, especially after pandemic, mostly open source software development, YouTube tutorial, education. Yeah.
Wow. Thanks for sharing that. How do you get into doing some open source? Because I'm imagining, you're talking about a lot of ArcGIS, Esri. That's quite the opposite scale of the open source side, but those are very powerful tools. So how do you start getting involved with the open source side?
Yeah, so when I was doing my PhD, so I developed some of the ArcGIS plugins, basic extensions that you can build on top of this. At the time was ArcPy and very low level stuff. But I think the frustration was because ArcGIS update their software all the time. So newer, like once they release the new version, all the version they use is incompatible. So if you develop extension was for ArcGIS 8 point something, 9 point something, and then they have 10 point something, it's broke. And I was working with my advisor and then help develop some of those stuff. It's kind of getting a lot more challenging to keep updating because once something becomes popular, people want to use it. And then when newer version release, they're going to install it. It doesn't work. And then we come back. So they will reach out to my advisor asking like, can you help this? And then my advisor will forward to me asking to help updating those. And it was a very time consuming. And later on, I think in 2014, 2015, I started using Python and then start learning how to do like automation. And then for me, it was so much easier because usually it will not break unless like from Python 3 point, 2 point something to 2.7 to 3 point something. But most of the time it's like backward compatible. So for me, I think it saved a lot of time. And also the other one was inspired by Dr. Zhong Lingji of Whitebox. Because it's very powerful. Initially it was developed using Java, but then later on using Rust. So I kind of extended using Python, R, Jupyter. So it makes it easy. You don't need to install a big software package on a computer like QGIS, ArcGIS, gigabyte. You just need a browser and then just couple megabyte and then you can start doing analysis and you can show people how to use that just using a browser. You can develop notebook. People just click, open the link and then they can run, right? So for me, the barrier is much lower. So I love teaching my students in class and also people outside the university how they can utilize those free open source software to do some geospatial analysis. It cannot do everything, but for me, most of the time, most of the job that I used to the past that I was not able to do, now I can do it. And the other nice thing about open source is that if there's anything, there's a bug or something, you can fix it by yourself if you know how to do it. Or you can just report an issue. Sometimes the issue get resolved within a couple hours, within the same day. If you're using commercial or desktop GIS or others, sometimes it takes weeks or months before people can look into that because it's so complicated. So for me, it's more like simplified version and I have full control. So if I develop from scratch, I know exactly what's the problem and then can fix it so quickly. So for me, it's basically save a lot of time. It's a lot more efficient. But I still use desktop GIS from time to time. But nowadays, mostly I write my own code. I will know what it does. If I need something, I just write some functionality into those existing packages.
Yeah, I think it's also this sort of analogy of like teach people to fish rather.
Yes, exactly. Rather than give them fish. Yeah.
Yeah, there's a few things I'm curious. Like one of the big elements of work that you've done is around like Google Earth Engine being, some of the education or like building some tools on top of it. But it's not really on the open source side. And so it's something I've been quite wanting to ask you is like, what do you think of Google Earth Engine? Like, what do you see its value for you? Is it something that you teach to students? What's your relationship with Google Earth Engine and how do you see it?
Yeah, I think it's a great platform, a great tool for, especially for remote sensing. I think I started using that since 2017. So it's 6 years now, and I really enjoyed it because it makes so much easier for you people to do large scale cloud computing. Traditionally, right, you have to download the data to a computer. You need to have data storage. Even if you have storage, you don't have necessarily have to compute to do global scale. So one of the big benefit of using that is now you can pretty much do global scale analysis because most of the images in there kind of cover the entire globe. So you can do global studies pretty easily if you can write the algorithm that can do the data processing. So it empowers a lot of applications. For example, simply global surface water mapping, global forest cover, a global land cover. Those things would not be possible without these cloud computing resources. So Google Sensing makes it so much easier to use, and also it lower the barrier. Like I said, you just need a browser. You don't need to install big package of desktop GIS, right? And it's also free for research and education. So think about those resources. If you have to pay, you have to build things on your own. It's going to take you so much time. So the analysis that I would give people is that when you're trying to watch a movie, right? You can certainly still go online to buy the DVD and then you have a DVD-ROM, try to play and then watch it. But not many people are doing it nowadays, right? You just go online, you watch a movie on Netflix, Amazon, or YouTube, right? And you just need a browser as long as some internet. So this kind of the transformation from using desktop cloud computing, desktop computing of doing remote sensing transform to cloud. Certainly, I mean, besides Google sensing, Microsoft Planetary Computer and also AWS are also, they are building those things that makes it easy for big use. But so far, Google sensing is still the most popular one. A lot of people use it in academia. A lot of people publishing utilizing that one. And certainly to me, I think it's transformative because now I can teach my student how to do like global scale or statewide studies very easily with a couple lines code, and it's a couple seconds. It's instant. It wasn't impossible in the past. So I have to have a big like hard drive to store all the data if I want to do like statewide study or global studies. In the past, I have to go to USGS to download data, go to NASA. But now, just open a browser and into a couple lines, you can get the things done. So for me, it's a big benefit for the academic, for students, or even for startup or companies that would like to do some larger scale studies.
One of the main topics that I like talking about with people on this podcast is things about business models and like longevity from a financial point of view. And Google Earth Engine now, as we speak, early 2024, has a commercial license. But it's still like, it feels like a commercial desktop like approach, but on the web browser, in the sense that you can't really know what's under the hood. It uses JavaScript if you're using directly the interface, which is not really the language of a lot of data science, which is where some of your work like geemap comes in. But I always feel a bit of reticence in like pointing people towards Google Earth Engine, because it feels like a little bit of a walled garden in and of itself, from the language, from the data. Like you get people a little bit addicted, and you used to, it's very easy to get the compute very quickly, but you haven't taught really people to fish. I'm curious what you think about that.
Yeah, I think it's for me, the commercial version actually is good for the community, because I'm always skeptical about anything is free. Someone has to pay the bill.
Exactly.
So to me, before they released the commercial version, I was like quite skeptical how long this is going to last, because it's a lot of money, right? The storage it's huge. Right now, it's like over 100 petabytes. Think about how much does it cost to store all those data. And compute is another big thing. So there are hundreds, thousands of people using it all the time. So anytime if it's free, I guess it's not going to last forever. There's no free lunch forever.
Yeah, exactly.
Someone has to pay the bill. And if they have the commercial version, I think it's a good thing. It makes it more sustainable, because at least they can make some money to subsidize education and academic use, because right now we're using it for free. But for me, for example, as a researcher at a university, nowadays, most people, like I said, if you want to do large scale studies, you have to use some kind of cloud computing. There's no way you can handle those large amount of data locally. So if I have to pay those like by myself, it's going to cost me a lot. You need some big grants to actually to cover that. And it's just not possible. For me, even if you don't want to fully rely on it, you can still use it as a platform to explore the data. You can see what data in there. You can see, because eventually you are going to run analysis. You don't have to fully rely on Google sensing, but the data you want to use are pretty much the same, right? If you want to use Landsat, Sentinel, SAR data, it's all over there. It's just the same data set. The only thing is that the compute, although it's kind of black box, but it has the API that expose that allows you to do that. And unless you're really a developer, they develop some low-level stuff. I mean, most people don't need to task how they do the median filter, how they construct the mosaic, because if you just want to do some simple length cover classification, you just need images. You just do a simple composition, and then just couple lines, you can get it done. You can certainly do it on your own. You can download data. It's the same, but it's going to take you so much longer. So to me, I think it saves a lot of time, and it allows you to get large amount of data very quickly, and also do computation very quickly. Certainly, Microsoft Planetary Computer or AWS have some similar, but you need to do some low-level stuff. So Google Sensing, basically, they build on top of the API that you don't have to do those like under the hood, how to mosaic them. And so if people don't want to fully rely on it, it's fine. You just need to build the algorithm, build the workflow on your own. But it's not for everyone. So to me, I mean, most of people, for example, my audience, like trying to learn geospatial, most of them don't have the skills to learn how to put those things together. So you better, like, to me, kind of similar, I would like give an analogy. Like right now you're trying to learn how to use a computer, right? You can use Windows, you can use Mac, or you can use Linux. So to me, I would like argue that maybe Google saying this is like Windows machine. And then those low level one more like Linux. If you know how to use the command line, how to do the stuff, it's fine. But most people just want the interface. They want to do something, they want to click, and then they want to get it very quickly. And yeah, it's still very the predominant one. I mean, desktop environments. But for me, right, I don't use Windows. For all my work, I use Linux. But when I'm teaching my students in class, I use a Windows machine because most of them want to follow the screen. They want to use the same thing. So I haven't used Windows for the past 5 or 6 years. It's only for teaching when I have to, but because I enjoy automating stuff, and Linux just makes it so much easier. I don't have to go online like to this website, to that website to download and then install. I just use a basic script, install the system, and then run the script. It's up and running. Everything I need is ready. And there are a lot of things that makes it so much more efficient than using a Windows. But certainly Windows right now have those PowerShell and other stuff makes it easier. But still, in terms of doing like GPU, cloud computing, other stuff, I mean, Linux is so much easier to set those environment up. So yeah, I mean, to me, I'm not locked into a certain platform. I want any tools that can make my work easier, more efficient. I love to use it. If someday something goes away, there will always be some kind of replacement. It's not going to be exactly the same. So to me, I think it doesn't really matter. Use whatever tools that makes sense, makes your work easier, more efficient, and try to keep it or be open-minded. Something goes away, you learn the other stuff, but it's a different level. You might need to spend more time doing this stuff. For now, Google Sensing is still very easy for doing remote sensing and also for teaching. So that's just my point of view that a lot of people are a little skeptical because they don't know how long it's going to last. But as long as they have the commercial version, they have the term of service that they need to last for certain years. They cannot just kill that right away.
Well, I mean, it's Google. They have a history of killing projects.
I know. This is the concern that people have, but at least for the foreseeable future, I think it's going to be there. Yeah.
Is that something that there's a couple of things I want to follow up. Is this something that you teach your students? Like, is that something that you mention? Like, hey, if, there's no free lunch, if there's this compute, this storage, not just Google, but in general, is that something that you bring up?
Yes. Yeah, I teach in class. I say to me, I think it's like important to learn the concept, to learn how to do this cloud computing, how to do things in the cloud. Once you learn this stuff, you can easily transfer the knowledge to other platforms. But if you have never used it, then it's going to be a problem. The learning curve will be pretty steep. But Google Sensing makes it so much easier. So you know those high level stuff. And at least you can use the same concept. You want to deal with some of those packages or open source doing cloud, XORA and other stuff. It's pretty much very similar, although it's not exactly the same. But to me, if you really want to follow the trend, what's popular right now, you have to know some of those stuff. But it's transferable. So to me, it doesn't matter what platform you're using. It's more like learning how to learn. So if you know how to learn by yourself, it doesn't matter. So for me, it's just a tool, a platform that allows you to learn. And once you understand the high level concept, how they do the cloud computing, why it's so much faster, what's the mechanism behind. Although I don't know the detail, how the engineering build those things up, but I know the high level, right? How can you make this more efficient? How it's running behind the scene, how it's doing the composition, doing the filtering. And those things, if you know, you can also do things on your own if you know how to do the coding by yourself.
So let me ask you, if there was no free lunch, let's continue on that. What about open source? Isn't that like a free lunch in a way?
Yeah, it's a free lunch, but nobody's serving you the food. You need to actually, there's no service. You need to pay. So for example, it's free lunch, but the free lunch is it's in the restaurant. You need to go pick up by yourself. nobody delivering the lunch to your door that doing it for free forever, right? Just like the city government, they have some food for some of the people that cannot afford to buy the food. But it doesn't mean that they're going to deliver the food to your doorstep because you're homeless. They don't know where you are. You have to figure out how to get it. People might be willing to help you, but there's no obligation that they need to help you, right? And you are relying on people's kindness to help you. And similarly, right, I love to helping people, but my time is limited, right? If you email me, you're not going to get response immediately because I have to teach, I have other stuff. But when I have time, I certainly will try to answer those questions quickly during my free time. But yeah, you either pay to get the delivery to your door, and if something goes wrong, they give you a replacement, or you go forget the food by yourself, or even you have to cook, right? You need to go to the store to buy the grocery and then cook yourself. Just like the analogy I used to give in the past is, okay, right now I need a spicy fish dish, right? There are two ways. You can go to a restaurant, you just order, they give it to you, you eat. Or you can go to the grocery store, you buy the fish, buy all the ingredients, and then you go home and cook by yourself. Either way, your purpose is to eat. So, I mean, most people, if you want to save time, I will go to a restaurant, just order, and then get delicious food. So to me, kind of like Google saying, you don't have to worry about what ingredient you need to get. You just tell what I want. I want this fish. Oh, I want the lancet. Okay, 1 liter Coke, get the lancet. I want this steak. I want it to be fresh. Yeah, get the current day, yesterday. And then, okay, I want it to be spicy. Okay, I do the mosaic and something like that. And then get it done. Certainly you can do it by yourself, but you have to go get the fish. You need to go fishing and then or go to the store to buy. If you want to fresh fish, yeah, good luck. There may not be fresh fish, live fish in the grocery store, right?
I like a good food analogy. This is great. The next thing I'm curious, you talked about, tutorials and helping people, and you have like a, pretty successful YouTube channel where you put out a lot of stuff and a lot of tutorials and helping people. And I know how much work this is. And that's like quite different from a lot of open source development. Like a lot of people write code, but it's a little bit in the background. If you're contributing, you see it. But you're also present in like telling people how to use it. You're not just doing the thing. And I'm quite curious as to what led you to do that and like why are you doing that?
Yeah, I think this because I'm an instructor. I'm a professor at university. I teach my students, so I love teaching. And the other thing is, when I spend some time on something, I want people to know it. I want people to use it. Otherwise, my time is not widely used. So go back to the analysis that we gave earlier, like teach people how to fish rather than giving the fish. And there are a lot of cool stuff out there. The geospatial community is huge and there are a lot of fantastic projects. But many of those people may not know or they may not aware, or maybe the bar is so high that not many people know how to set things up. Or, I mean, in general, even new to geospatial, new to Python. Even try to install the Python package sometimes can be very frustrating because you need to install pip and then, it doesn't work. Or install even GDAL, right? Or raster.io. Some of those things are not easy. You need to actually know how to create those virtual environment, how to install the packages. So because I came from there, I know how sometimes challenging it is to just set up the environment, installing the packages. So that's why I try to lower the barrier, not just teaching people how to set things up, but also teach them how to build, right? So I teach a whole course, teach my students how to build open source packages and how to contribute to the open source community, how to create videos, how to create tutorials, how to create notebooks, how to make things more reproducible and more accessible. So basically, I'm teaching whatever I know, what I'm doing daily to all my students. So I want more people to come to the geospatial and also more people to contribute. And the more people can contribute, you're going to get better and better. So that's kind of a mission that it's also selfish because once I put things out there, I get emails all the time, people asking how to do this, how to do that. And if I record a video, I don't need to explain again. I just send the link.
Yeah.
Check out this video. I have covered this before, and you can just follow the instructions. If they have further questions, they can open an issue on GitHub. Then I can follow from there to resolve the issue. So for me, it's also time saving me a lot of time without me to repeatedly teaching or explaining how to do this and do that, because most likely it has been covered. So if I develop something, add a new feature, I want people to use it. And also I usually create a short demo teaching you like what this is about. At least you can get something, because everyone is busy. You need to get basically gain the attention, people's attention. So if you just put a text out there and it's not very attractive, people are not going to spend time. And so I think it's great. We need to actually do some kind of marketing. Even if it's open source, it doesn't mean that people are going to use it. I mean, by default, if people don't know your existence, then they're not going to use it. Even if people know your existence, they don't know how to use it, it's still a barrier. But if people know that there's something exists, it can do this stuff. I've seen a demo before that you can visualize these images. Then they will go back to check, and then they follow the tutorial, they can do it. So basically, getting some attention and also makes it easier for people to use and allow people to try it out. People will remember. Otherwise, you're spending time that's not getting enough attention, and it's waste of time.
Yeah, so it's like a marketing even for...
Yeah, this kind of marketing. Yeah. Certainly, marketing for the packages, but eventually also you might get some personal recognition. People know you because you're doing the stuff.
I think you may have answered partially this question, but I'm still curious. Like, why videos? Why not text or even notebooks? Is a it's hailed as a medium that's really good for telling a story or making it very easy, and you can have hosted notebooks and things like that. So why video?
Yeah, good point. So for me, like for all the open source packages, I try to have some kind of notebook, Jupyter notebook that you can follow through, and also video. I'm not a native speaker. I'm writing very slowly. So for me, when I'm speaking, like it's not authentic, it's not like native speaker, it's fine. I can just record a 20-minute video and it's done. If I have to write down all the text, you need to figure out like is there some kind of grammar mistakes or how to make it better. It's going to take you like hours, like for the same course. So for me, I use a live teaching like online demo and then get it done, and then student can go back and rewatch it. Certainly, it'd be nice to have something that also have a document or blog like describe everything. But for me, it's like I don't have time to do that, and it's not the major focus of my time, because I can certainly do that. Then I will have less time to develop those packages. I have less time to record the video. So if I have 48 hours, I'll probably do that. 40 hours. Yeah. But it's not perfect. I also have a blog, but I just don't have time to keep updating it. To me, writing, developing software is so much easier. Those codes, you don't need to worry about the syntax and other stuff. You need to talk, Python, you need to follow the syntax, but I'm talking about like language.
Yeah, I understand.
If I'm a native speaker, probably it's just much more natural. But for me, you need to in your mind, need to translate. And then, because when you put something out there, you want to make sure that it's high quality. You don't want to put something like just ChatGPT to automatically or YouTube to automatically convert, because I have a strong accent. So even those videos, when I never watch my video after I upload to YouTube. But sometimes, because some people tells me like something's wrong, I go back to watch it. And if I turn on the caption, you can see YouTube is having difficulty trying to translate my English into like text. And sometimes I just feel like I don't want to watch it. I know it's not perfect, but I don't care. Once I put something out there, if you like it, you like it. If you don't, just ignore. But I usually don't go back to watch, because it's too much time trying to, this is not perfect, I need to cut this one. I used to spend like when I first started recording the videos, like I think in 2020 during the pandemic, I was so shy because I've never really put myself out there, like speaking and then video. And so after record the video, I have to go back and then just re-record because this is not worth it and then cut. A 20-minute video end up spend like 1 to 2 hours just to do the editing. And after a couple times, I say, okay, fine. This is not, my time is not well spent. It's not my focus. My focus my mission is to teach people. My mission is not to say perfect English. So as long as people understand what you're talking about, that's fine. So now I just gave up. So none of my videos are edited. It's just record, upload, that's it, and then done.
That's so interesting that like making a video is faster than writing, because I think for a lot of people it's like the other way around. But you make a very good point about like native languages, which I want to come back to. But before that, do you encourage your students as well, like, or other people to do the same thing? Like to like, I really like this idea of marketing your projects as well. I think it's something really useful and important. Is that something that you like push people to do as well?
I've never pushed my students to that, but I usually recommend. So especially if you want to become some kind of a GS analyst, or you want to get a job after you graduate, it's great to have some kind of internet footprint out there. So my recommendation usually would be just search your name on Google. See how many pages you need to scroll before you find your name. If you're not on the first page, not on the second page, then probably it's very unlikely people want to find you. So if you're doing programming, the starting point is GitHub. GitHub, because they do this search optimization. So it's pretty easy for people to find you. So if you have something to demonstrate, then you can certainly make it easier for people to find you. And you can demonstrate your project, your stuff, your contribution, and something like that. So that's more like technical for GS doing, students doing GS stuff. And not many people are comfortable with like creating a video, put your names out there. Even for myself, all my video, you really see my face, because when I'm teaching, when I'm recording the video, I don't want to turn on the light because it might be at night, 10 p.m., 11 p.m. I don't want to dress up. I just don't want to spend time doing those stuff. It be just the screen recording. That's it. So even in class, I don't turn on the camera because to me, it's great to have, but I don't want to pay too much attention to my face. And so for me, it's more important the skills that you want to teach, the information or the message you want to convey in the video. And I usually recommend my students to get started with just putting some open source projects, blog posts or something like that. And at a certain point, when you are comfortable with putting your face out there or video, then go ahead and do it. It's great because the more exposure you're going to have, the more likely people are going to find you. And you also need to be cautious about putting up too many stuff. Sometimes there may be something weird stuff in your video, other stuff. People, when you become like well-known, then you have to pay special attention because people might find something that you didn't say correctly or whatever. So, and it's kind of sometimes a double-edged sword. So you have to be careful. But it's beginner. I don't think it hurts. You be active on social media, on GitHub, or LinkedIn, and then try to interact and then get some insight, learn something new, and then eventually you can start developing your own social media stream, your packages, your video, and then sharing with people. Slowly you will get more and more attention. So that's usually I would recommend, unless you are very shy, you're not comfortable, that's fine. But you need to be technically very strong if you want to go in this route to do like programming and also software development.
Another common theme that seems to come up a lot when I have these conversations is around language, not like Python and JavaScript and R, but like, English. And I'm very fortunate that English is not my native tongue. But we traveled when I was very young and I got to speak English very young. And now I'm very thankful that I speak very good English. And I'm curious, like, what do you think about, you were saying you want to lower the barrier to entry a lot, but English is still a pretty big barrier to entry to a lot of people. And is that something that you think about, like putting things in other languages? Yeah, or if you've had exposure, I'm guessing you speak either Cantonese or Mandarin. And do you do any of the work, in either languages? I'm always curious about that.
Yeah, so I'm actually from Guangdong, so my hometown speaks I don't know what language called Chaoshanghua. It's kind of close to Taiwanese,
Okay.
kind of see the same dialect. But when I went to school, we learned Mandarin, and because we're also close to Hong Kong, so when I was a child, so we like watched a lot of like TV shows from Hong Kong, so we also learned Cantonese. And then when I went to university, high school, we started learning some English. So in terms of like geospatial and also education and teaching, I think the majority of my materials in English, but I do teach sometimes in Chinese for some workshop or some invited talks at the university in China, but mostly just virtual presentation. So I did have some uploads on my YouTube channel that's Chinese, but I don't speak other Spanish or other languages. So for me, I think nowadays, if anyone, want to learn some like geospatial cloud computing, there's no way you can avoid English. So you have to learn some pretty basics. But like I said, you don't have to be a native speaker because most of those like languages, that's like syntax, Python, R, or Java, whatever, it actually not super difficult. So you don't have to speak like perfect. You can still learn. So for me, even when in the early days when I was learning ArcGIS or others, I always wanted to look at the official documentation in English because I have to do some translation. Sometimes some of the things are not like it's weird. The translation was weird, so it's good to learn the documentation. And also, for me, it's important to learn those terms or whatever used in those software. And then once you learn that, it's also much easier for you to find, if you have questions, it's much easier to find help, how to formulate a question in simple English. And there's nothing complicated because the vocabulary in those program languages are not super high. It's mostly defining variable classes and something like that. And so usually I would try my best to produce those things in English. Chinese would be unless like invited they want me to speak Chinese, then I will speak Chinese. And the nice thing about those videos, because YouTube nowadays have automatic translation, right? So you just turn on the a caption for your country, then you automatically translate. It may not be perfect. There are even some people offer to help me translate some of the videos into Spanish, and then they get the subtitle, and then I help upload back to YouTube so that they can it's become more a better translation basically. Yeah, so I think that's kind of right now the technology also with all the ChatGPT, all the AI stuff, it gets so much easier. So I think it's becoming less and less a barrier. It's good something to know, but like I said, you don't have to be a perfect speaker, native speaker. As long as you can understand that, that's fine. Get the work done.
Yeah, I appreciate that. I think that's a great thing to mention. Do you ever look on YouTube analytics? You can see like which language people subtitle in. Have you ever looked at that? Like,
Good question. I think I've like maybe I look at it once every half a year, couple months. I don't check my YouTube analytics
that's not a
because
bad
to me it's
thing.
more like education.
Yeah.
And usually like the obvious one was like how many subscriber, because when you log into the YouTube studio you can see that. But I never really look into like where like countries, mostly from the US, from India, and but YouTube is blocked in China, so there's
Yeah,
no actually
that's
check it.
also something I wanted to ask. Yeah.
Yeah, but it's like Europe, Canada, like, but I don't pay too much attention to those because to me, YouTube is more like a platform for me to um change for the knowledge, to teach people how to use it. But I don't really use it as kind of way to make money to be on purpose, like target certain audience, because to be honest, right now like YouTube pays me probably 70 or 80 cents per day, less than $1, right? So for the whole year, I may get like $300. Like I can work for a company in 1 hour, I can get $300. So I don't have to spend too much time trying to do that, but I want to keep producing a video so that it's not dead. It's not alive. So I have video every week. I'm teaching, so I can record the video and put online so students can go back and rewatch it. So basically to keep the momentum going, try to produce at least a video every week. And it's kind of a opportunity maybe to lead to other opportunity, but it's not for like making a living. I think you need like 100,000 or 1,000,000 subscribers to make a meaningful meaning. Otherwise, it's like $1 per day is like, yeah, it's not going to help you much financially.
Yeah. Well, it pays for the restaurant to get some nice spicy fish every once in a while.
Yeah, yeah, that's true. Yeah.
Yeah, Qiusheng, I feel like this is actually a nice place to start rounding the conversation off. I like asking people for a book and a podcast recommendation at the end, mostly because I feel like it's a nice way to just learn a little bit more about what people are interested. And I feel like books and podcasts travel a lot through word of mouth and through recommendation. So is there anything that you've read or listened to recently that you think is interesting? Not necessarily about GIS or remote sensing or anything, just, interesting things that you've come across.
Yeah, I have to be honest. I don't read books a lot. So
that's fair.
I'm pretty busy. And most of the books that I read are rather specific to GIS and rather technical. So the most recent one that I read is the cloud-based remote sensing with Google Sensing. The one that edited by Dr. Jeff Cadil and a couple other editors, basically about learning about Google Sensing, and has 55 chapters, over 100 authors. So it's a pretty nice collection. Two books. Even though I know Google Sensing for a couple of years now, I don't know every detail. So it's still nice to learn some of the basics. Learning. So I recommend the audience, if you are really into cloud computing, want to do some larger scale data processing, it might be a good book as a reference to learn. And it has different applications, right? Atmospheric, urban planning, forestry, all kind of stuff. So it's great to pick some of those and then use some example to get your work done. And the other book that I was reading was the Geospatial Data Analytics on AWS. So it's also like another platform, how you learn some cloud computing stuff on AWS for doing geospatial. Sorry, those are more like the technical books.
That's fine. That's great.
I don't read other books like in general life or science fiction. I just don't have time for that. So
yeah, I get
and in terms of podcasts, I listen to it like when I'm driving all day from home to school. Your podcast, Mine's Behind Maps, and also Mapscaping podcast. And other than that, I usually listen to some like news radios, news podcasts, sometimes like that. But yeah, that's pretty much what I have. I don't watch movies. I don't listen to music. I would love to, but I just don't have time for that. So
yeah. I mean, you're doing a lot. So yeah, I'm surprised you even have time to read and listen to those.
Yeah.
Yeah, Qiusheng, thank you so much for sharing some of your story, some of everything you've done. Really appreciate it.
Yeah,
it's been great.
Thank you very much for the invitation. I really enjoyed the conversation. Thank you very much.
Hey, thank you so much for listening to this conversation. I wanted to take a moment to thank the sponsor of this video, but also all the people who financially support me on Patreon. If everything goes well, these conversations should feel and sound seamless and effortless, but there's a lot of work that goes behind the scenes. I try to research and prepare these as much as I can to know who these people are and what makes them interesting and what would lead to a good conversation. I'm incredibly thankful to all the people who support my work on Patreon, meaning I can do a little bit more of it. This podcast started out as a way to learn more about the people in this industry, but I've also started making educational content on another YouTube channel that I'll put a link to in the show notes. And I want to make more content explaining how satellite images and maps work to a broader audience, as well as continuing to research the guests for these podcast episodes. So if you value the work that I do, I'd like to ask you to please consider supporting my work on Patreon. There's also some behind the scenes of how this podcast is done and some of the work that I'm doing for these educational videos if you want to learn more about how I do all of this. Either way, thank you so much for all of your attention and your time. I really appreciate it, and I hope you get value from these conversations. Thanks.